So I've literally been teaching the whole time. I haven't had a break yet.
Oh, yeah, she's had like a phone.
Yeah. I've just been teaching like geometry all day.
That sounds really fun.
Oh, it is.
Sounds so fun.
I'm ready for spring break.
3 weeks.
We got this. At least this week is a short week.
Yeah.
Thursday and Friday are virtual.
Mm-hmm. And so is Tuesday of next week.
Okay. Wait, really?
Because it's ACT.
Oh, I forgot about that.
Wait, Thursday, Friday this week?
Yeah.
Yeah. But we're still learning. We're just learning virtually.
Yeah.
So.
Hey guys, so on the 25th and 26th of this week, these will be virtual days. The 24th and 25th will be your test days. So the 25th, everyone will be online taking the test. So Wednesday and Thursday of this week, you have a test. Thursday and Friday this week, you are virtual. Does anyone have any questions about like the calendar or anything? Okay, wait 1 second.
Miss Keith, I'm sorry, could you repeat that?
The 25th and 26th of this week will be virtual days, and your tests will be the 24th and 25th, so Wednesday and Thursday.
Okay, thank you.
You're welcome. Okay, so today and tomorrow we're just going to review. Okay, so let's get started. Okay, so a lot of these problems you're going to be using the distance formula. So you have to know how to use the distance formula and the slope formula. So if it just asks for the distance from A to B, we're going to be using that distance formula. So it's x2 minus x1 squared plus y2 minus y1 squared. Okay, so we do x2 minus x1 squared plus y2 minus y1 squared. So I'm just going to call A x1, y1, and I'm going to call B x2, y2. So we get 2 minus a negative 7, so it's like 2 plus 7, plus negative 4 minus 5. And we get 9 root 2. Okay, so we're going to skip these. We're just going to do number 7. Okay, so we're trying to find the slopes between L1, L2, and then we're going to see if they're parallel or perpendicular, or neither. So I'm going to call this one x1, y1. I'm going to call this one x2, y2. And then I'm going to do this one x1, y1, and call this one x2, y2. Okay, so do y2 minus y1 over x2 minus x1. So we get negative, or sorry, we get positive 1. Okay, and then we do these next two. So we do y2 minus y1 over x2 minus x1. And we get negative 1. So look at 1 and negative 1. Are these parallel, perpendicular, or neither? Okay, so a hint is that we can say 1 is over 1. So I have 1 over 1 and negative 1 over 1. So are they reciprocals? Can you flip it and it'll be the same number? What about, are they opposite? So are they opposite signs?
Yes.
Yeah, so these are perpendicular. So you flip them and make them opposite signs. So 1 over 1 is going to be perpendicular to negative 1 over 1. Okay, so you also need to know how to find what type of quadrilateral we have. So use the slope formula and the distance formula. So I'm going to skip the diagonals. I'm just going to show you how to do it with sides and slopes. So remember that under 3-1, we have this little parallelogram chart. So if it's a parallelogram, then the two opposite pairs of sides are congruent and parallel. But with the trapezoid, only one side is parallel. So parallelogram has two sets of parallel sides. Trapezoid only has one set of parallel sides. So if it's a parallelogram, it can be a rectangle, a rhombus, or a square. So if it's a rectangle, that means that you have 4 90-degree angles. That means that the slopes are perpendicular. If it's a rhombus, then it just means all 4 sides are congruent. If it's a square, it means it has all 4 sides are congruent and it has 4 right angles, so we have perpendicular slopes. So we're going to use that for number 9. Okay, so our first step is just to graph this and look at it. So we have the point -3, 1. We have the, oh, sorry, -3, -1. -3, -1. We have the point -4, 2. We have the point 5, 5. And we have the point 6, 2. Okay, so just looking at it, what type of shape does that look like? What type of shape would you say that is, Alexa?
A rectangle?
It's rectangle.
Yeah, so it looks like a rectangle. So you have to check all 4 sides. So you check A to B, B to C, C to D, and D to A. You also could have said A to D, it would have been the same thing. Okay, so I'm going to call the first one x2, y2. I'm going to call the second one x1, y1. Okay, so we get -1 minus 2 over -3 minus -4. So plus 4, and we get -3 over 1. Okay, now we do BC. So we do 5 minus 2 over 5 minus -4. And we get 3/9 or 1/3. Okay, then we do C to D. So we get 2 minus 5 over 6 minus 6. Or is it? Wait, let me see. C to D, 2 minus 5 over 6 minus 5. So I get -3 over 1. And then we do D to A. So we do 2 minus -1 over 6 minus -3. And we get 3/9, or you get 1/3. Okay, so look at our slope. We have -3 over 1, we have 1 over 3, -3 over 1, and 1 over 3. So sides are parallel. We know that it's a type of parallelogram. But there's also another thing we noticed. So what is the relationship between -3 over 1 and 1 over 3? Are they perpendicular, parallel, or neither? Yeah, so these are perpendicular. So that means that we have a right angle. So which 2 shapes can we narrow it down to? Do you know, Edmund?
Is it square and rectangle?
Yeah, we can narrow it down to a square and a rectangle. So because we know that the slopes are perpendicular, we know that it has to be either a rectangle or it has to be a square. Okay, so after you check the slopes, check the distances. So we're going to do the same distances. We're going to go from A to B, B to C, C to D, and D to A. So since it's a long process, I'm just going to do A to B with y'all, and then I'll give y'all the rest. So for A to B, we get -3 minus 4. Sorry, minus -4. And then we get -1 minus 2. So I put this all in the calculator, get the square root of 10. So now at BC, we check CD and we check DA. So BC is 90, CD is 10, and DA is 90. Okay, so look at these. Are these numbers all the same or only opposite sides the same? I don't know. Do you know? Are opposite sides the same or are all four sides the same? The ones in green. Yeah, so only opposite sides are congruent. So is this going to be a rectangle or is it going to be a square if only opposite sides are congruent? Yeah, it has to be a rectangle. Okay, good. So this must be a rectangle because all four sides aren't the same. So because we checked the side lengths, we know that this is a rectangle. So we were right when we said it looked like a rectangle, it actually was a rectangle. Okay, so the next thing you need to know how to do is do the partitioning of line segments. Okay, so I'm going to do number 13 with y'all. So our formula is x1 plus a over a plus b times x2 minus x1. And then y1 plus a over a plus b times y2 minus y1. So this formula always works, so always use this formula. There's another one that I gave y'all at one point, but that one has certain things that it doesn't work with, so just make sure you're always using this formula. Okay, so ignore that. We're just doing 13. Okay, so we're trying to find the point that partitions 0, 6, and 5, -4 in the ratio of 2 to 3. So first, let's talk about the ratio. So if the ratio is 2 to 3, that means we have 2 parts, and then we go over 3 parts. So how many total parts do we have? So if we have 2 parts and 3 parts, what's the total?
5 on.
We have 5. So the denominator is going to be 5, and then the numerator is just your first number of the ratio. So our actual equation, or sorry, our actual fraction is 2 over 5. Okay, so now we know our fraction, so now we can plug it into our formula. So our formula is x1, so if it doesn't tell you what segment it goes first, then just call the first one x1, y1, and call the second one x2, y2. But on the test and in normal situations, it'll tell you either A, B, or BA. If it says it partitions it at AB, that means call A x1, y1, and call B x2, y2. But if it says it partitions BA, that means call B x1, y1, and call A x2, y2. So the order does matter for these, and it'll normally tell you. On the test, it'll tell you. Okay, so I do x1, so x1 is 0, plus our fraction, times x2 minus x1. So I get 5 minus 0. Okay, and then we do y1, 6, plus our fraction, times y2 minus y1. So put all of this in a calculator, you get 2. Calculator, and you also get 2. So the part that partitions it is 2, 2. Okay, does anyone want me to go over another problem like this? Okay, so you also need to know how to graph circles. So we're going to do number 17. So we haven't really done a lot where x squared is greater than 1. So anytime you see something, if the number beside x squared is greater than 1, divide by that number anytime you see it. So if it's in standard form, if it's in general form, you're just going to divide by that number. So we actually get x squared plus y squared equals 25. So what's my center? Y plus, equals 25. So now just looking at that, what is my center?
0, 0,
Yeah, so our center is 0, 0, and then what's my radius?
5.
Yeah, our radius is the square root of 25, so our radius is 5. Okay, so I start by plotting the center, and then I go a distance of 5 away from the center on both sides, and then 5 up and down. So that is my circle. So on the test, you'll have a circle, like a graph of a circle, and you'll have to find the center and the radius.
Maybe one like 18 or 19.
Okay, so Alexa, what would the center of 18 be?
-2, 0.
So our center would be -2, 0, and then what is my radius? Yeah, so it's 4. So I start at -2, 0, and then I'm going to go a radius of 4 away. So I'm just going to count 4 away from our center. So I go over 1, 2, 3, 4. So we're here. Then I count 4 away on the left. 1, 2, 3, 4. So we're here. Then I count up 1, 2, 3, 4. So we're here. And I count down 1, 2, 3, 4. So we're here. So just start at the center and then count that many away from it.
Okay, thank you.
You're welcome. That was a good one to do. I'll do that one in my other classes too. Okay, so let's try 21. So we're going to find the center and the radius. So the center, you really just have to look at it. So our center would be this point right here. That's the middle of all the points. So our center is at -1, -2. And then my radius is going to be, let's count how far away the center is to the edge of the circle. So I count over 1, 2, 3. So I have a radius of 3. Okay, now we plug it into our formula. So we do x minus 1, so we get +1. And then y minus -2, so we get +2. And it equals our radius, so it equals 9. Okay, so you also need to know how to go from general to standard. So like I said earlier, had there been a number in front of x squared, you would need to divide all of that by it first. But since it's just x squared, we don't have to do that. So our next step is to move the constant over. So I'm going to move the 9 over. And then I'm going to put my x's together, and I'm going to put my y's together, and I'm going to add little boxes. Since I add 2 boxes on the left, I have to add 2 boxes on the right. Okay, our next step is to take the number beside x and the number beside y. So we divide it by 2, and then we square it. So what's -4 divided by 2? And what's 2 squared? So can someone tell me what my right-hand side equals? So it just equals 4. And then my left-hand side is going to be x plus or minus something squared plus y plus or minus something squared. So go back to our number beside x, divide it in 2, so you get -2. Go back beside the number beside y and divide that by 2, so you get y plus 3. So what is our center from this equation?
2 negative.
Yep. And then Haya, what's my radius?
2.
It's just the square root of 4. Okay, good. Let me know if you guys have any questions as I'm going over this. I'm kind of going quickly just because we've already done this so often. Okay, so you also need to know if a point is on the circle, outside the circle, or in the circle, and you also need to know tangent lines. So we did both of these on one day last week. Okay, so let's do number 27. So we're working with this equation right here. So my very first step is to convert this into standard form. So we can't find the center unless it's in standard form. So let's go ahead and put it in standard form. So we get x squared minus 3x plus some number plus y squared plus 8y plus some number equals 20 plus some number plus some number. So we're just going to do the same exact thing when we did in the last problem. So I'm going to take the -3, I'm going to divide that by 2, and then I'm going to square it. So when I do that, I get 9/4. So you can put that in your calculator if you don't know how to square a fraction. You're really just squaring the numerator and squaring the denominator. So you get 9/4. Okay, and then I go to my 8y. I divide 8 by 2, and I get 4, and then I square that, and I get 16. So 16 goes in my next box.
Wouldn't it be negative 9/4?
Well, if you square a negative, it makes it positive.
Oh, okay.
So anytime that you're adding a box, it's always going to be a positive number. Okay, so I put this all in my calculator, and I get that it equals 38.25. So now I get x plus or minus something squared plus y plus or minus something squared equals 38.25. So go back to number beside x divided by 2, so I get -3/2. Go back to my number beside y, divide that by 2, and we get y plus 4. Okay, so what is my center?
3 seconds and -4.
Yeah, so we get 3/2 and -4. And then my radius is going to be the square root of 38.25. And the point that we're looking at is 2, 4. So remember, if something is inside a circle, that means that our distance is less than the radius. So let me just draw that out here. So if it's inside the circle, that means that our distance is less than the radius. If it's outside the circle, that means that our distance is greater than the radius. And if it's on the circle, that means that the distance is the radius. So now we're going to check the radius, and we're going to check the distance from the center to the point, and we're going to check if the distance is greater than, equal to, or less than the radius. Okay, so let's find the distance from our center to our point. So I'm going to call this one x1, y1. I'm going to call this one x2, y2. So our distance is x2 minus x1 squared plus y2 minus y1 squared. And we get the square root of 64.25. So this is my distance. This is my radius. Which one is bigger? The square root of 64.25 or the square root of 38.25? Yeah, so our distance is greater than our radius. So which case are we? Are we outside, on, or inside the circle? If our distance is greater than the radius? Yeah, we're outside the circle. So our final answer is that it's outside. Okay, so another thing you need to know how to do is write the equation of a line tangent to a circle. So the first step is to graph it and find center. So let's graph it. So center of the circle is at -6, -5, and the equation of the line is tangent to the circle at -1, 7. So it's like right here. So remember, a tangent line means that it intersects the circle at one point. So here's our tangent line. Also remember that a tangent line is perpendicular to the radius. So what we're going to do is we're going to find the slope of the radius, and then we're going to find the tangent slope. So first thing is graph and find center. Our center is -6, -5. Our second step is to find the slope of the radius. So it doesn't matter that they gave us the slope. What we need to do is find the slope of the radius. So to find the slope, I call the center x1, y1, and I call our point x2, y2. So we're finding the radius from -6, -5 to -1, 7. So I do y2 minus y1 over x2 minus x1. And we get 12 over 5. Okay, our next step is find the slope of the tangent. So remember that the tangent is perpendicular to our radius. So what number would be perpendicular to 12 over 5?
5 over 12.
So our slope of the tangent is going to be perpendicular to that slope. So you just flip it and make it opposite sign. Okay, our next step is to plug it into y equals mx plus b. So right now we're trying to find the b. We don't know what the y-intercept is. But what we do know is that we have this point, -1, 7, and we're going to plug it in for x and y, and we're going to plug in our slope, that's -5 over 12, and we're going to find what b is. So I plug in 7 for y, I plug in -5 over 12 for the slope, and I plug in x is -1. And then we're trying to find b. So I multiply these two, and then I move that over to the left-hand side, and I get b equals 79 over 12. So our very last step is to plug it back into y equals mx plus b. But now we're just doing the general formula. So we're not going to plug in x or y. We're just going to plug in our slope and our y-intercept. So leave y the same. Plug in our slope, that's -5 over 12. Leave x the same and plug in our y-intercept, which is 79 over 12. And then that's your final answer.
Can you go over step 4 one more time?
Yeah. So we're going to plug it into y equals mx plus b. That's our slope-intercept form.
Okay.
So you
Okay.
just use one of the points. I think you could still use the center and you'd get the same thing. But I just always use the point that it tells us, and I plug in the x value for x and then the y value for y. And then plug in your slope, the slope of the tangent line for m, and then solve for b.
Okay, thank you.
You're welcome. Okay, so are there any questions over 27 or 28? It's really important that you guys follow these steps. Okay, so let's see which one we want to do. So these are a little bit too difficult. I'm just going to go over the homework problems I had last class. So let's see which one we didn't do. Or did we do all of them?
We went over the one, I think.
Okay, let's just go back over 3 and 5. So don't worry about those two problems on the review sheet. They're a little bit more harder than what you'll see on the test. So just make sure you know how to do the ones for triangles. Okay, so we're trying to find the perimeter and the area of this triangle. So what I'm going to do first is I'm going to calculate the area, but you could have done perimeter, it doesn't matter. So let's find the area. So let's find our base. So we could call this part our base. So any point that's straight across or straight up and down, call that your base. Alright, hey guys. So your test will be tomorrow and Thursday. So just make sure that you're logging on. Thursday will be a virtual day, so my in-class students, you guys will be on your computer, so just make sure that you're still completing the tests. So Thursday and Friday of this week will be virtual. I think Friday is just asynchronous, so we're just going to give you an activity to do on your own because we're going to be getting our shots that day. So just make sure that you're here for Wednesday and Thursday to take the tests. Today we're going to finish up that review sheet, so you guys are just going to work on the rest of it for homework, and then you're going to submit it on Teams. So let me take attendance really quick, and then we'll get started. Okay. Okay, so let's find a slope of a line parallel to y equals x minus 2. So what is my slope for number 5? Yeah, so if there's nothing beside x, just put a 1 there, so it's like 1x minus 2. So anything that's parallel to that, so parallel, it's just going to be the same slope, so it's going to be 1. If it's perpendicular, though, you flip it, so I put 1 over 1, and then I make it opposite sign, so it's negative 1 over 1. Okay, now let's look at 3/2 x minus 3. So what is my slope there? Yeah, so my slope is 3/2, so if it's parallel, it's just going to be 3/2. So it's the same slope. If it's perpendicular, it's going to be flipped in opposite sign, so it's going to be negative 2 over 3. So you flip the fraction and make it opposite sign. Okay, so you also need to know how to find what type of quadrilateral we have. So this is on your past quiz. So use this sheet tomorrow, this little parallelograms chart. It'll help. So let's go ahead and graph this. So we have negative 3, negative 3. Oh wait, I messed up. Negative 3, negative 3. We have 1, 1. We have 5, negative 3. And we have 1, negative 7. Okay, so just looking at it, what type of shape does that look like? Yeah, so it looks like a square. So let's go ahead and solve it and see if we actually have a square. So first up is find slopes. I'm not going to go over the process of how to find the slopes since we did that yesterday. I'm just going to give them to you. So find the slope from A to B, from B to C, from C to D, and from D to A. So you get 1, we get negative 1, we get 1, and we get negative 1. So what do you notice about these slopes? So we have 2 pairs of parallel sides, or 2 pairs of parallel lines because we have parallel slopes. So 2 sets of parallel slopes because we have 2 sets of congruent numbers. But what also can we notice by them? Are they perpendicular?
Yes.
Yeah, so they're perpendicular. So what type of shape do I have? Or what 2 shapes can I narrow that down to?
Rectangle and square.
Yeah, so since we have right angles, since we have perpendicular lines, we know perpendicular slopes, we know we have right angles, so it must be a rectangle or a square. So from this, we know that's either a rectangle or a square. Okay, now let's check the distances. So once again, we're going to check from A to B, B to C, C to D, and D to A. So if I check these, I get that they're all square root of 32. So for the slopes, you're checking for parallel and perpendicular lines. For distances, you're checking for congruency. So is it going to be a square or a rectangle if all four sides are congruent? Yeah, so it must be a square. So because we know that all four sides are congruent, we know that this is a square. Okay, let's see what else. So we're going to do number 12. So we're going to partition this line segment. So remember, partition just means cut it. So we're cutting it at a ratio of 2 to 3. So what that means is that we're over 2 and we're away 3. So how many total parts do we have? If I'm 2 away and then 3 away.
5.
Yeah, so we're a total distance of 5 away. Or sorry, we have a total distance of 5 parts. So that's going to be my denominator. My numerator is going to be the first number in our ratio, so it's going to be 2. So let me go ahead and write down that formula again. So point P, our point of partition, is going to be x1 plus a over a plus b times x2 minus x1. And then it's going to be y1 plus our fraction times y2 minus y1. So always use this formula. So if it doesn't tell you that it's partitioning at A to B or B to A, you can just choose the first one to be x1, y1, and the second one to be x2, y2. But normally these line segments are called directions. These are directed line segments. So if it's directed, that means that the direction matters. So if it says from A to B, that means call A x1, y1, call B x2, y2. If it says B to A, that means call B x1, y1, call A x2, y2. Okay, so we're going to plug in our x1. So our x1 is negative 2, and then we're adding our fraction. And then we're doing x2 minus x1. And then we do y1 plus our fraction times y2 minus y1. So I put all of this in a calculator and I get 4/5. And I put all of this in a calculator and I get, what was it? -1. So this is your final answer. Okay, so now let's try number 18. So can someone tell me what my center of number 18 would be? Yeah, so our center is -2, 0. I'm going to rewrite this equation. So x plus 2 squared plus y squared you can write as y plus 0 squared. So opposite of 2 is -2. Opposite of 0 is 0. So you get the point 2, 0, -2, 0. What's my radius?
4?
Mm-hmm. So our radius is just the square root of this number. So the square root of 16 is 4. Okay, so now to draw this, we're gonna go to our point at -2, 0. So that's my center point. Now I'm gonna go a radius of 4 away from it. So I move over 1, 2, 3, 4, and I get this point. And then I move over 1, 2, 3, 4, and I get this point. And then I go 4 up, and then I go 4 down. And then I just connect my points. So that's our circle. Okay, so if you get a circle and it's asking for the equation, you really just have to look at it. So it looks like right here is our center. So that point is 2, 3. Now let's find our radius. So our radius is from the center to a point outside the circle. I mean, on the circle, not outside, on the circle. So now let's count how many units away we are. We're 1, 2 units across. So that must mean that our radius is 2. Okay, so now let's set up an equation. So it's x plus or minus something squared plus y plus or minus something squared equals 4. It's the square of 2. So what's opposite of positive 2? Yeah, so you get negative 2 here. And then what's the opposite of positive 3? So negative 3 goes in that second point. Okay, we're almost done. We just have one more. So remember that you need to know how to find the tangent line and also how to find area and perimeter. So the shapes that you get will be a little bit easier, so don't worry if you don't get the last two on this review sheet. They're going to be more similar to the 3.18 homework that we did. So just make sure you know it, you understand the 3.18 homework. Okay, so let's try number 22. So we're writing the standard equation from general form. So you're going from general to standard. So my first step is to look at the number beside x squared. If it's anything other than 1, let's say we're 2, you would divide by that number first before you did anything. So you divide all of it by 2. But since it's just 1, we don't have to do anything. So my next step is to move the constant over. So I'm going to subtract 10 from both sides. And then I'm going to put my x's together, and I'm going to put my y's together, and I'm going to add little boxes. Or actually, the x's and y's are already together. They already put them together. So since I added a box on the left, I have to add that box on the right. So now I take the number beside x and the number beside y. If it didn't have a number, then you would just leave it. It'd just be y squared. Like, let's say it said plus y squared plus box. You could rewrite this as y plus 0y, and then you'd get 0 to put in the box. Or you could just know that if there's no number beside y, it's just going to be 0. Okay, so we take this number and I divide that by 2, and then I square it. So what's 2 divided by 2 squared?
1.
Yeah, we just get 1. Okay, then we take the number beside 10, and I mean beside y, we get negative 10 divided by 2. So negative 10 divided by 2 is negative 5. Negative 5 squared is 25. So what does my left-hand side equal?
16.
So our left-hand side equals 16. So you get x plus or minus something squared plus y plus or minus something squared equals 16. So I take the number beside x and I divide that by 2. So 2 divided by 2 is 1. So positive 1 goes in this box. Then I take the number beside y and I divide that by 2. So negative 10 divided by 2 is negative 5. So you get that. So, and then what's my center?
It is. Oh, it's 4.
Well, that's my radius. My center is just going to be the opposite of whatever's in parentheses. So what's the opposite of positive 1?
-1.
What's the opposite of negative 5?
5.
And then you said our radius was what?
4.
So our radius is the square root of 16. And then my center comes from the opposite of whatever's in the parentheses. Okay, so you guys should probably be bored of that. We've done a lot of those. So just make sure that you study the tangent that we did yesterday. It's right here under Unit 5 review. You can use these notes on your test, but just make sure you know where everything's located. Also, go back over this parallelogram sheet. Okay, so that's all I have for today. So you guys are just going to finish up that worksheet that we started yesterday and today. And then I already took attendance, so you guys can just log off now.
Bye, thank you.
Bye, thank you, Whitley.
Bye, have a nice day.
Bye. Thank you, Ashley. Thank you, Kyler.